One of the properties of waves that is specific to transverse waves is polarization. So we can select a certain vibrational direction of a transverse wave because it both vibrates up and down and side to side. So here we have a wave that's vibrating this way, and it's vibrating this way, and it's vibrating this way, and so forth and so on. But now what we're going to do is we're going to pick a direction in which it vibrates. We're going to pick one of those axes and just do that one. So for the purposes of light, we only discuss the electric field portion of the wave because that is what generates the magnetic field portion, so they're related, so we can ignore the magnetic field portion, and we're just going to discuss the electric field. So let's send this unpolarized light through a polarizer, and so it strips out everything that doesn't pick in the direction that I don't want it to go, and what I'm left is with some light that only vibrates in one direction, or along one axis. So let's take a look at what's called the picket fence analogy. So we have a rope, it's vibrating up and down, and we have, it makes it through this first one here, and then when I have another picket fence, I can send the wave through. They're both aligned, they both can go through. Here I've got one picket fence, and I'm sending the wave through. It makes it through that first one, but my picket fence here is turned sideways. And so it blocks that light. So I can now control my light a little bit differently using these polarizing filters. Incidentally, the first company to make a polarizing filter was Polaroid. So now another way that we can polarize light is by reflecting off a non-metallic surface. So the tables in our room, your hair is another good one. It's got to be non-metallic, and that's because of the chemistry and the electrons and that kind of stuff, beyond the scope of what I'm trying to do here. So here I've got some light that's polarized vertically. You can see here's the electric field, and it's only vibrating up and down. So this would be vertically polarized light, and by vertically, just by where I am. I can make horizontally polarized light, and you can see these two are just they're 90 degrees to each other. One was just vibrating in the vertical axis, one is just vibrating in the horizontal axis. So where does this come from? Where can I use it? I'm sorry. So here's a picture of the ocean. You've seen this. There's the white frothy foam. Here's the beach. Everything looks great with no filters. When I send it through one of those filters, I can filter out just all of that reflected light off that water. And so now I can see a whole lot better here. This is why you have polarized sunglasses to block the reflection. Let's take a look at one more. Here's the sky. There's a lot of polarized light in the sky too. You can see here it's much darker up here because I've taken out more of that light. So this light is preferentially polarized, where down here, not so much. So let's go back one more, and based on what we saw before, you should be able to tell me what direction this polarization film is located and what is the right direction of the polarized light. I gotta be done. Okay, here we go.